Hi everyone, my name is Stefan Burns, and we need to have a pretty serious discussion about what is happening here on Earth geophysically and energetically. Right now, due to a variety of factors, both natural and man-made, we are in the middle of a process that I call Earth electrification. To put it simply, Earth is becoming more and more electrically active and alive. This is accelerating rapidly, and it's creating the conditions for a massive evolutionary selective pressure to be placed upon us. Not only that, rapid Earth electrification also has profound implications for our modern way of life on this planet, especially as we become increasingly technologically advanced and dependent. And if we're being realistic and honest with ourselves, there's no turning back from this. We're not returning to the simple times of the Neolithic as some hopeful hippies may want, unless we're forced to by powers far greater. More on that later. At the outset, I want to be very clear that this is not a doomsday apocalyptic proclamation. Que sera, sera, whatever will be, will be. That said, big changes are ahead of us though due to Earth electrification, which will affect us not only individually and collectively, but also Gaia herself. And thus it's important to be aware of and to be conscious of the massive geophysical changes that are occurring here on this planet right now. Earth is an amazingly fertile and resilient place here in the cosmos, and I have a feeling that ultimately she'll be just fine, just as she has been in the geologic past. It's us I'm more concerned about, and therefore I think it's important to live by the old Scouts motto, be prepared. In fact, I have a feeling that Earth is relishing in this electrification process overall as it's helping her to become more conscious. I'm not going to water anything down in this presentation. We'll drill into the details, but first, here is the basic overall thesis. Planet Earth is a very special place full of life and energy, and this is largely in part due to our close proximity to the Sun, which continuously bathes the planet in radiation. We're protected from the strongest of this radiation by the powerful magnetic field that emanates from the core of the planet, and the uppermost part of the atmosphere, known as the ionosphere, will typically absorb whatever gets through that magnetic shield. This helps to maintain and drive the global electric circuit, or in other words, the flow of energy across the entire planet globally. And this drives a variety of natural energetic processes, like lightning, for example. There are about 50 lightning strikes per second happening on the Earth at any given moment in time. These strikes produce electromagnetic waves, some of which propagate out across the entire planet, and they combine together to form stable energy fields because they are naturally resonant with the Earth itself. Interestingly, human brainwave rhythms have the exact same 0 through 50 plus hertz frequency range as these Earth resonances, and at the same intensity. We evolved in these Schumann resonances, as they are known, for millions of years, and our innate resonance with the Earth allows us to have an easy exchange of energy and information between us and Gaia. Furthermore, lightning strikes on Earth and neural spiking in the brain are scale invariant. All of this and more suggesting that humans are fractal microcosms of the Earth itself. With all that in mind, what happens if lightning strikes become more frequent globally? Lightning strike frequency has already been increasing for decades, and this is expected to compound and increase by a further 50% by the end of the century. Superbolts, 100 to 1,000 times greater in strength, are also rapidly increasing in frequency. Storms and cyclones are getting bigger, faster, stronger, and they're happening more regularly as well. And not only is the Earth warming overall, but the weather is becoming more volatile and extreme. For every degree Celsius that global temperature rises, the atmosphere can hold 7% more water vapor, and lightning strikes increase by 10 to 12%. What we're seeing is rapidly accelerating Earth electrification, and that's just one part of it. A huge factor driving Earth electrification beyond our anthropogenic impact is the Sun. For 300 years now, solar activity has been increasing, with the solar maximum that we're in right now being the latest in this grand solar maximum period. And solar cycle 25 has been much stronger than predicted, meaning more energy is pumping into the Earth than there has been in over 2 decades, and the world looked quite a bit different 2 decades ago. There has been a widespread expansion of power grids and cellular networks since the turn of the millennium. Power grids induce what's known as power line harmonic resonance, causing greater ion precipitation from the radiation belts, and cellular networks are now operating at gigahertz frequencies, which is absorbed super easily into water due to its electric susceptibility. These factors and more pumping increasing amounts of energy into the atmosphere and entire environment around us. And we also have satellite megaconstellations. A satellite megaconstellation is expected to be composed of 40,000 plus satellites, each weighing more than 1,000 kilograms, and there will be multiple megaconstellations in the near future. As satellites reach the end of their operating lifespan, just about 5 years, they are decommissioned and they burn up into the atmosphere, distributing fine-grained aluminum and other metallic particles into the near-Earth environment and upper atmosphere all over, greatly increasing the conductivity of these delicate geophysical layers. Just a single megaconstellation will add about 150 million times more mass to low Earth orbit than the entire mass of the radiation belts daily. How exactly this highly conductive shell of metallic particles floating around the entire planet is going to affect the Earth is still unknown, but we have some educated ideas. We know that when solar storms impact the Earth, they cause magnetic perturbations felt all the way down to the surface, something that's known as a geomagnetic storm. It's supercharged electric currents in the radiation belts and also the ionosphere that cause these swings in Earth's magnetic field strength, which then induce electric currents in Earth's surface. The geomagnetically induced currents from most solar storms don't present a problem, but the strongest solar storms can increase the power of GICs so much that they can overload power grids, causing them to collapse. This is well known. And this is exactly what occurred in Quebec in 1989 from a G5 geomagnetic storm. Solar storm impacts are going to become increasingly severe as the enormous amount of metallic satellite dust amplifies the geomagnetic storms that we have in response. And compounding to all of this is the enhanced flow of extremely high energy ions from the solar storm flowing deeper into Earth's atmosphere than normal because of the innumerable magnetic ducts that now connect Earth's surface to the space environment due to power line harmonic resonance and high power gigahertz frequency cellular networks. Our increased expansion of technology will bring about the very conditions that could cause its collapse upon a sufficiently powerful solar storm impact. And these sort of powerful solar storms have occurred before. We have the infamous Carrington event of 1859, the Great Storm of 1872, 1921, and some lucky misses in 1972 and 2012. And those weren't even from the most powerful types of solar flares known as superflares. A huge spike in radioactive carbon-14 isotope in 774 AD suggests that Earth was slammed by a superflare so powerful it's estimated to have been an X400 in strength. The Carrington event is estimated to have resulted from an X64 solar flare, while the three main severe G4 to extreme G5 geomagnetic storms that we've had thus far in solar cycle 25 all resulted from solar flares less than X10 in strength. Superflare impacts are known as Miyake events, and they are absolutely in a league of their own. And they occur more frequently than people realize. We have evidence of Miyake events scattered throughout the recent geologic record. The most recent one in 774 AD caused a ground level enhancement 70,000 times greater than normal background levels. It was an electromagnetic pulse of energy the entire Earth experienced, far beyond modern comprehension. And almost certainly, if it was to occur today, it would cause a colossal power grid and technological collapse, huge satellite failures and ablations, and massive acute health problems globally. Though humanity is confidently walking along the path towards greater technological advancement, it very well may inadvertently divert us back to a more Neolithic way of life because of how our technology is dramatically amplifying the potential strength of solar storm impacts and the resulting geomagnetic storms. Increasing Earth electrification and greater energy volatility across the planet is also going to stress our biology to greater and greater degrees, very likely leading to a big evolutionary selective pressure where those with stronger, more adaptable bioelectric systems will have better fitness in an evolutionary sense, and those who don't won't do so well. Just 150 years ago, a very short time duration in the geologic sense, the only energy in the radio and microwave part of the light spectrum came from solar flux and lightning strikes, both of which are fairly low in power, but now we've dramatically increased the power density across a wide swath of the light spectrum because of the creation of power grids, radio communication, and cellular networks. This is already causing an unprecedented silent health crisis, and the increasing geophysical energies outlined stacked on top of that will only increase the evolutionary selective pressure to adapt to living in higher energy flux environments. That's the basic premise for Earth electrification and the general direction that the Earth is headed energetically in the near future. I know it's a lot to digest. It's taken me a lot of time, research, and thought experimentation to better understand what's happening on the Earth geophysically, to come to some of these conclusions, and to understand how this may affect us physically, societally, and perhaps even spiritually. As Earth acceleration continues due to solar activity and also the efforts of humanity, it'll be interesting to see how Gaia responds, because I have a feeling that Gaia is going to become more conscious than ever before. She'll start to make whatever decisions she needs to that are best for her, and hopefully we're on the right side of that. By being aware of this profound energetic shift that we're in, at a minimum, you can best prepare for it health-wise and societally. You can connect to Earth consciousness to an even greater degree, receive those beneficial downloads, and hopefully thrive in the energetic chaos that is ahead of us. Now let's dive deeper into some of the different things that I outlined in the introduction to this video, because as Earth electrification continues, an open question is, how is it going to affect us? We are naturally resonant with the Earth herself. We are microcosms of the Earth. And so if the Earth is continuing to electrify to greater and greater degrees, we can assume that that's going to have pretty profound effects on us, not only biophysically, but also perhaps consciously and more. So one really interesting thing is that there is a scale invariance that exists between the Earth and ourselves. We see that with lightning strikes and neural spikes. So we look at a neuron. They have a lot of electrical activity to them. They produce a neural spike, and it's all these different spikes across the brain that create brain waves. If we look at the actual volume of the brain or the skull, just in general, and we look at the intensity of a neural spike and we calculate the energy density, we get about 10 to the -7 watts per meter cubed. Now, if we look at Earth's lightning, we look at its electromagnetic intensity, and we also calculate the area where lightning is able to exist on the Earth, basically the troposphere. We get an energy density that is exactly the same at 10 to the -7 watts per meter cubed. This is scale invariance. Basically, lightning strikes on Earth and neural spikes in the brain are scale invariant, meaning that there is a shared universality between them. Examining each system as a whole, Earth and brain, they also both produce 0 to 50 Hertz electromagnetic fields at the same picotesla strength. These are the Schumann resonances that I mentioned. So lightning strikes here produce electromagnetic frequencies across the entire light spectrum, going from close to 0 Hertz all the way up even to gamma rays. Specifically like superbolts, the most powerful lightning strikes can produce gamma radiation. And so we clearly see the visible light here. We know that they produce also ultraviolet light and thermal light and a whole bunch, the entire radio frequency spectrum. But the lower you go in frequency, the less that electromagnetic wave will attenuate. So a gamma ray photon will absorb into something almost instantly. Visible light eventually fades out. But these extremely low frequencies, close to 0 hertz, they continue propagating out, and the ones that are naturally resonant with the Earth based on their wavelength, being harmonic to the circumference of the Earth, they form these stable energy fields known as the Schumann resonances. Those Schumann resonances have frequencies at 8 hertz on average, 14 hertz for the second harmonic, 20 hertz for mode 3, 25 hertz for mode 4, 33 hertz for mode 5, 39 hertz for mode 6, and 45 hertz for mode 7, and they continue to go up, though they decrease in strength as they do across all the modes, and sometimes you won't see those super high modes of the Schumann resonances, but they basically go out to about 100 hertz maximum. That's exactly the same frequency range as human brainwave rhythms. We can measure different brainwave rhythms: 0 to 4 hertz, delta rhythms; 4 to 8 hertz, theta rhythms; 8 to 12 hertz, alpha rhythms; 12 to 30 hertz, beta rhythms; 30 plus hertz, gamma rhythms. And we've measured brainwave frequencies going beyond 200 hertz, though typically at a very low intensity. Most of the power in brainwaves are at the lower frequency part of that range in the delta, theta, and alpha band. And we also see that also with the Schumann resonances, where most of the power is contained at that foundational 8 hertz mode, which is right at the boundary between theta and alpha for our own brains. Not only do they have the same frequency range, they also have the same intensity. That's very important if there is this resonance that exists between ourselves and the Earth, because you need there to be the same intensity for there to be an easy transfer of energy and information. If there isn't, then what would be a signal in one would be noise in the other. So if lightning strikes created Schumann resonances that were 10 times stronger than brain waves, then this would just end up being very overpowering noise for the brain. It would actually make it hard for us to have cognitive processes, because our own bioelectric signals would constantly be washed out by all this intense electromagnetic energy being created by lightning strikes and other aspects of the global electric circuit as well. The fact that they have the same intensity theoretically allows for this energy and information exchange, and that seems exceedingly likely and in some aspect kind of deliberate, because Schumann resonances almost certainly existed since the creation of the planet. Once we had an ionosphere, once we had a global electric circuit, boom, we had Schumann resonances. So therefore, for millions, more likely billions of years, these stable energy fields of light have existed, and we evolved in them from the very beginning, if our evolution story that we know is true, where we went from unicellular life to multicellular life to the whole progression up. But we see that we have these natural frequency resonances deeply ingrained in our biology. We know they have a bunch of different bioelectric effects. For example, like even a very weak Schumann resonance fluctuation can move electrons and cause protein conformation changes, and DNA, being highly conductive, responds to these natural fluctuations, and it can do things like change the bioelectric cellular voltage gradients in the body by changing how ion voltage channels open and close. There's a whole bunch of things. It's a whole world to explore if you're interested in it. But because we evolved in these, it very likely conferred an evolutionary advantage to be in resonance with the Earth, because it's also an energy saving mechanism. Perhaps even at times you receive some information from the Earth, which then is advantageous to you as an organism in the past, and you have better fitness as a result. There's a whole bunch to explore here. But at the very least, we see a scale invariance between these things. We also just see how they look the same. So sometimes when something is screaming in your face, it's telling you something. If you want to learn more about this scale invariance, I highly recommend you read this research paper here by Michael Persinger. It's linked in the video description. It will definitely blow your mind. While we're on the topic of lightning strikes, let's learn more about how lightning strike frequency is likely to increase till the end of the century, and perhaps even beyond. It depends on how the climate changes. And also let's learn a little bit more about superbolts, those most powerful of lightning strikes because they really are quite insane and definitely a telltale sign of Earth electrification and how it is accelerating. So here we have a few different climate models is showing lightning flash density annually across the globe. And so they ran it through a few different configurations. This is the most intense change in Earth's climate going to the year 2100. And then in this column here, we see that difference compared to the present day. So PD present day. So in this model here, just like a mild acceleration of climate change, we see that there is an increase in lightning flash density annually. We can see our scale bar here. Not everywhere has this increase. We do see some regions, for example, in our differential map that go down. See these blue colors. There are some regions that will experience less lightning, but overall, total mean lightning flash density is expected to increase due to climate change. And that is a result of a lot of different factors. Anthropogenic influences, just there being more water vapor in the atmosphere, and also solar activity. Here we see it gets quite wild. The lightning flash density really goes up. We see it very clearly here with our differential. Look at how the main lightning chimneys, Southeast Asia, the Africa there, Central Africa, and then also the Americas, has this big increase in lightning flash density, but also in general across the continents, we see that. We see that even the areas that are further away from those main lightning chimneys, we'll see an increase in lightning flash density. And with more lightning strikes, you get stronger Schumann resonances. You also get more VLF radiation, right? More of those light photons, ultraviolet, X-ray, gamma, though that's pretty rare, but we do get gamma rays produced from things like superbolts. They're increasing in frequency. Look at some data that we have here. This is solar cycle 24, which was a weak solar cycle. Definitely weaker than this one, and also weaker than the one before it, solar cycle 23. And we see superbolt frequency. So this goes from 2010 to 2018, and we see that as solar activity is increasing, we start to get more superbolts, whereas we basically didn't have any recorded superbolts during the solar minimum here in 2010. And then as we reach the peak of solar cycle 24, which again was a weak solar cycle, look at how the frequency, the occurrence of these superbolts goes up dramatically, up to beyond 1,000 for that monthly count. And then with every single peak there, look at that, right? Exactly aligned. And we see that also aligned there. It then subsides as solar activity goes back down to the next solar minimum, which then went from about 2018 to 2020. We are now in solar maximum for solar cycle 25. So I'm sure scientists right now are collecting this data. I don't have it available for you right now, but eventually that will be released. And I'm sure these numbers are going to be even higher because solar cycle 25 has been quite a bit stronger than solar cycle 24. Sunspots only went to just under 150 with solar cycle 24. We have sunspots now above 150 for solar cycle 25 for long stretches of time, the biggest count being 215, well above 150. And these superbolts can be massive. Check this out. This is a superbolt that was recorded April 29, 2020, 477 miles across. This is what I'm talking about, the superbolt. It's 100 times to 1,000 times more energy. So you get one superbolt, that could be like 1,000 lightning strikes simultaneously. Imagine the amount of electromagnetic energy that is releasing into the background field, causing and also amplifying this entire Earth electrification process. And also, in general, I think, raising the consciousness of the planet herself. If we discuss general resonance theory, then we can have a basis of understanding how the Earth can be conscious. So what is general resonance theory? General resonance theory is an idea that consciousness is based upon vibration. And the nested sequences of vibration and resonance determines the degree of consciousness. So this would attribute consciousness to everything. Even an atom, a particle, has some level of consciousness, though it may be very, very minor. But because everything in the universe is inherently vibrational, everything has some level of consciousness based on this theory. And it very much resonates with me. Then as you go up and the systems get more complex, then consciousness gets more complex. And so, of course, we see that there's a whole bunch of rhythms nested within our body across different frequencies. For example, blood pressure rhythms going up to heart rate variability rhythms, and then you have your actual heart rate, and then you go up to your brain waves, and it continues down and up all the way. And we know that humans are quite conscious beings, or at least we hope we are. Sometimes we don't act that way. But if consciousness is based upon the overall system of vibrations and resonance that exists, then we can expect the Earth to be a super consciousness, because not only does every single human on Earth live on Earth, in addition to every other animal, some of which are probably smarter than us in many aspects, whales, elephants, you name it. All of them living together on Earth, we are all part of that system, all meshed within those Schumann resonances. Earth has other energetic rhythms as well. There's telluric currents that pulse through the ground surface, those geomagnetically induced currents that I mentioned earlier. And there are these VLF waves created from lightning strikes. We have solar flux, which now becomes an energy inherent to the Earth. There's these other electromagnetic frequencies produced in tons of ways. I mean, we have lunar rhythms. We have a whole bunch of energies that kind of congregate here on Earth and stay here. Earth is receiving a good amount of energy from the sun based on its position in orbit. 1 astronomical unit away, we get on average about 1,360 watts per square meter on Earth at any given time. And so it's that energy from the sun which is driving all these different systems and keeping the energy humming and moving along. And so you can kind of imagine, visualize the Earth as a little humming vibrational electric thing, machine, system, consciousness being that's moving through the solar system. We are part of that. And if we get more electrical activity, more neural spikes, you could say, for the Earth, of course, we can imagine that the Earth is going through a period of higher consciousness and a growth into that. And we're going to be taken along for that ride because we are also resonant microcosms of the Earth itself. The part of Earth electrification that's being driven by human activity might not last for long though, and that's because as we continue to alter these delicate geophysical layers like low Earth orbit and the radiation belts with all that satellite dust that I talked about earlier, that could perhaps create stronger geomagnetic storms. That seems very likely. I think we're actually already seeing the effects of that. And with stronger geomagnetic storms, you get stronger telluric currents. These geomagnetically induced currents could then cause a widespread collapse of technological systems. We'll talk about that more later. But I wanted to discuss that because there is an inherent negative feedback loop that exists as a result of that. As we put more technology out into space and we create these systems, we pump more energy into our atmosphere with cellular networks and power grids and more. It inherently is creating a more volatile environment that's going to have a higher chance of destabilizing itself. So there is this negative feedback loop aspect that is in play that could kind of, you could say, knock us offline. But ultimately, what we're doing is creating an impulse on the planet that will have a long tail to it. And so I think this Earth electrification is going to continue for a while, even if, let's say, we're knocked out of the picture. I don't think that's likely. I think we'll find some way, maybe that Neolithic way. But this satellite dust, for example, is going to be in the atmosphere for a long time now, especially if we actually do get to that point where we have hundreds of thousands of satellites in orbit because there's multiple mega constellations. And also we have, for example, the fact that we've pumped out a bunch of CO2 and water vapor and methane into our atmosphere. And there are long geologic processes that occur to sequester that. The positive amount of emission that we've done in 150, 200 years far exceeds the rate of sequestration, where you get carbon being pulled out of the atmosphere, being sequestered at the bottom of the ocean, into the rock cycle and more. So there's going to be a long tail to this. And that's why I think there is some aspect of this Earth electrification process that the Earth herself is relishing in, because she needed that impulse, she needed that help to make this occur. and she doesn't necessarily perhaps need us around forever to continue feeding into that system. It only needs to be a transient pulse of activity, you could say. So in the context of that, and we really don't know where this is going to lead, I think it's important to be aware of some of the things that you can do to help improve your own health and wellness and to fortify against these coming energetic changes. Because what we see evolutionarily is that we're very adaptable organisms. And so what you do and what you do continuously will have long-term effects on you. The sooner you start practicing your own energy management, the more adaptable you'll become and the more resilient you'll be in the days, weeks, months, and years ahead. One of the things that's going to help us a lot are trees. We do have more carbon dioxide in the atmosphere. It's a warmer climate, and I think Earth is really going to be relying on trees to help balance all these energies. We see that trees have roots that go very, very deep. When I was doing some spelunking in Bulgaria, we actually went down into a cave like 60 meters and I saw tree roots hanging down. So you have these really big, strong roots that grow shallow, but you also have very fine, thin, conductive roots that go very, very deep. And so trees connect to all these different geophysical energies and they emit these biofields outwards due to the flow of ionic solution through their tissue. And so they create these very subtle electromagnetic fields. We also know that trees are able to, like large swaths of forest are able to help modify and control climate and stop erosion, and in general make the Earth a more pleasing place. So I think Earth is really looking at plant life more so than us for the future in terms of creating a very harmonious, beautiful place to live on. And one that's very conscious too because of how trees emit and amplify these natural geophysical energies through their own biologic structure. And knowing that, you can improve your own bioelectricity by spending time in natural areas, for example, a forest that has a lot of trees. We see with this graphic here how the flow of nutrients through the tree creates this biofield. So going outside, spending time in nature is a really important thing to do. Of course, can't discount a good diet, exercise, good sleep, drinking good clean spring water. Those are just the basics. But in terms of energy management, the extra step to take, one that's very much reminiscent of our evolutionary past and our lifestyle going up to just 150 years ago, is spending more time in nature, spending time grounded, connected to the Earth herself, keeping your electric potential neutral to the Earth, harmonizing your own biorhythms to the natural geophysical rhythms. This optimizes your hormones. It improves your circadian rhythm. The best way to do all this is to walk around barefoot where you can. So a nice park is a great place to do that. In general, just to connect yourself conductively to the Earth. Now, if you want some help with that and going around barefoot all the time is not practical for you, then on my website, Wildfree Organic, I do have all natural earthing shoes. These are the men's and these are the women's right here. And these shoes are very special because the entire sole of the shoe is conductive. It's made out of water buffalo leather. There is a copper plug at the K1 meridian, which helps you enhance that energy flow through your body to harmonize your overall bioelectricity and your biorhythms. Also the flow of energy through your chakras. And they have a zero toe drop, wide toe box, so they help with natural toe splay and foot posture, and your feet will get stronger. A very important aspect of this entire thing is to make sure you have strong feet and good posture. You want the flow of energy through your body to be very nice. And so I wear these earthing shoes when I'm out and about, and it's not practical to be barefoot, but I still want to be connected to the Earth electromagnetically. They, for example, will still work even on concrete, anything that's conductive. The only time these don't work is basically if you're walking on asphalt or something that's not conductive. So if you're in the house, typically the house is not going to be conductive and connected to the Earth because there's wood that's used, or you're on the second floor. So they're not really super useful for grounding yourself in the house. But if you're out and about, even concrete, you're walking on a forest trail, you don't want to walk barefoot, but you're still out in a natural setting, these shoes will keep you conductive. You can go to wildfreeorganic.com/store to check them out, as well as other holistic wellness products that I make and offer for you all. So those are some of my thoughts as to this Earth evolutionary impulse that we are in right now, how that may affect us, how to best adapt to that. Again, I think the key really is being grounded as often as possible and to be consciously practicing earthing, developing your connection to the earth, developing that coherence that you have with her, allowing for that energy and information exchange. Because personally, in my own life, I have multiple instances where I feel like I have received information from the earth that's been beneficial to me and has greatly helped me with my life. She's a super consciousness. Of course, she's going to know what's good for us. I think she has tabs on all of us. And so developing that perhaps will keep you out of harm's way as well. She's going to go through some pretty volatile changes. Weather systems, again, as I mentioned, will be enhanced, greater temperature differentials, just bigger storms, things of that nature. So listening to your intuition, connecting to Earth consciousness, I think is going to be absolutely key as we move forward, especially in the context of big, powerful solar storms like Carrington events or even Miyake events, which are possible and will be enhanced in strength under the current Earth electrification process that we are in right now. Due to the widespread rollout of power grids over the past 200 years and also radio frequency technology over the past 100, and really both of them over the past 50 years, this has been a primary driver of Earth electrification up to this moment in time. We have to look at the light spectrum that exists here on Earth in general to get a sense of how impactful this is. Most of the energy in the light spectrum typically is at visible frequencies, also infrared, and then ultraviolet light because of the sun. Then we have very slight peaks in the density, very low intensity at some of the frequencies that outline Schumann resonances. If you get a lightning strike or a storm near you, VLF frequencies in the kilohertz range, things like that. Solar flux coming down from the sun at megahertz frequencies, but again, very low intensity. Now with radio microwave technologies, that part of the light spectrum has been dramatically boosted up in strength, and we know that there's biologic effects to this, but beyond just the biologic effects, we know that we're just pumping a bunch of energy into the atmosphere because an electromagnetic wave is energy. Where does it go? Why, for example, do they need so many 5G cell towers? The reason why is because since it is a higher frequency wave, beyond gigahertz now, in the gigahertz range, you need more of them because it attenuates out faster. In fact, gigahertz frequency is right when water starts to preferentially absorb it due to its susceptibility. And as a result, water is absorbing most of that gigahertz frequency, so you need a whole bunch of these towers. And as you add more water vapor into the atmosphere, we don't know the effects of that, but we know that we're charging up water throughout the entire atmosphere and also ourselves with the widespread rollout of gigahertz microwave radio frequency technology like 5G. That was one of the main drivers up to this moment in time. It still will be a very big driver. I think there's certainly effects that has on the weather. Also, power grids and radio frequency technology is what's helping develop these magnetic ducts that go through the ionosphere, allowing ions to go from the radiation belts down into the lower atmosphere. That could be one explanation of why there's more widespread aurora from these weaker geomagnetic storms than have occurred in the past, because you just have more open channels for these solar particles to flow down and then to interact in the atmosphere, creating air glow and all the cool things that we see with a powerful geomagnetic storm. But that also means that we could have more frequent ground level enhancements, which can also be biologically stressful, and it's a huge topic to explore. But now one of the main drivers of Earth electrification are going to be satellites, because this is a very delicate geophysical layer. Most of the mass for the Earth is the Earth itself, right? The solid mass of the Earth is where the majority of the mass is. And as you go up, the mass decreases and the energy increases. So at the surface, you have the air, and it's not that ionized. There's actually almost zero ionization of the troposphere. Only under very rare, unique situations can the conductivity and the ionization of the troposphere, the lowest part of the atmosphere, the 0 to 2 kilometers boundary layer, can that increase. But as you go up, eventually there's greater amounts of ionization. You have more plasma that exists. The the ionosphere, starting about 50 kilometers up, but going all the way up to 1,000 kilometers, is weakly ionized, about 1%, but still quite a lot. And then as you go out to the radiation belts, you have them predominantly being made of these extremely energetic relativistic ions. These are charged particles moving near the speed of light, but there's very little mass there. Very little mass comprises the radiation belts, but the overall energy is very, very high, affects the global electric circuit. Well, look at this. All these satellites that we've now blasted into space, each one weighing 1,000 kilograms or more, they are just contributing a massive amount of mass now to a geophysical layer that before was very, very, very low mass. And not only is this mass there now in the first place, it's also extremely conductive because we're using metallic materials. And so aluminum and steel and titanium and anything else that they're using will eventually break down and create a bunch of new ion populations. You'll have Al3+, and you'll have a whole bunch of free electrons that are created as a result. And that is going to linger in the atmosphere, the uppermost parts of our Earth, for we don't even know how long. We don't know what the processes are to cause that to eventually filter down or to kind of, let's say, evaporate away. But we also know that metallic ions have some heft to them, right? The nucleus of a metal ion is quite heavy. So we can expect some of them to eventually rain down, precipitate down. How's that going to affect us in the air we breathe and the soil and all these things? That's also a very big open question. But this layer of conductive material around the Earth is going to respond very easily to now changes in Earth's magnetic field. If you have a solar storm impact come in, it pushes the magnetopause at the Sun-Earth boundary closer in, moves the plastosphere closer into the planet, causing ion precipitation. These electric currents that are going to be generated now with this additional metallic layer surrounding the planet are going to be very strong. And we know that magnetic fields can induce electric currents in anything that's a charge carrier. If there's something that's conductive, you have a magnetic field that's varying, you create an electric current at that same frequency. Whereas if you have an electric current, you will generate a magnetic field at that same frequency. So basically we get these magnetic field swings that kind of propagate down into the radiation belt and into the ionosphere, generating these electric currents, which then pulsate at the same frequency. They generate their own magnetic field swings, which then add on or subtract from Earth's magnetic field. That is what we register down at the surface. These are the swings in the magnetic field strength that we register during a geomagnetic storm. They can be 1,000 nanotesla in strength or more, though usually they'll top out around 1,000 nanotesla. They're strongest at the poles. They're weakest around the equator, these geomagnetic field fluctuations. But the stronger those fluctuations are, the stronger the electric currents that are induced in the Earth's surface, these geomagnetically induced currents. And if those keep getting stronger, it'll be impossible for technological systems to be able to resist them because they'll simply just overload the system completely, because technological systems are made up of a whole bunch of conductive materials. You have these wires and you get these currents to get induced in these long transmission lines. There's no way to really shield that because they're super low frequency. And now you have a much stronger voltage across that line that's 100 kilometers long, 1,000 kilometers long, and it'll blow out the transformer, it'll blow out the substation and cause the entire collapse of that part of the power grid. And if it's a really big storm, huge parts of the power grid. That is all possible. We saw that in 1989 with a very big geomagnetic storm. The DST index went down to negative 589. For context, the Mother's Day storm that we had in May 2024, a very powerful geomagnetic storm, at its lowest went down to negative 412 on the DST index. And we saw widespread power outages in Quebec because of those geomagnetic induced currents that overloaded the power grids there. From a really powerful solar storm impact with the Carrington event in 1859, we know that certain telegraph stations actually exploded into flames because the currents that are flowing on those telegraph wires were so strong. Some operators even turned off the power and were still able to communicate to each other using just the natural geomagnetically induced currents that were propagating along those telegraph wires. Now our technological systems are way more advanced than 1859 or 1921, but we haven't been hit with a flare like that since 1921 basically. We've had some lucky misses, and we haven't been hit with a Miyagi event since 774. That would just be on a scale unlike anything seen, and how Earth is going to respond to it now with all this satellite metallic dust, this enormous amount surrounding our planet, and increasingly more every single year, that's a complete unknown. I want to go a little bit more in depth on geomagnetic induced currents because this is really a key aspect of how our expansion of technology could cause its own collapse from a very powerful solar flare like a super flare. So here we have the sun, and there is an explosion on the sun. We call these solar flares. And this one happens to launch a coronal mass ejection. A whole bunch of solar mass from close to the photosphere gets ejected out into interplanetary space. It's now headed directly towards Earth in this example. We see the CME propagating here, and it's composed of a whole bunch of different solar particles. So typically hydrogen ions, also alpha particles, electrons, and more. They are as a plasma in a coherent unit traveling. It has its own magnetic field, and when it sweeps by the Earth, the solar wind will increase in strength to what the strength of the magnetic field of this solar storm is, and we'll have this huge injection of solar particles into Earth's magnetic field, into the plastosphere. So these particles then distribute across the entire magnetosphere and plastosphere, and they cause the magnetic field to rapidly vary. That's what we discussed. And these magnetic field variations then induce these electric currents in the plastosphere and in the ionosphere, most notably the ionosphere, which then create those electric currents, which induce geomagnetic induced currents in Earth's surface. Those would be known as tellurics, but also now that we have these power grids in anything that's conductive basically. So a transmission line, as discussed, made up of aluminum in the core, or perhaps copper or steel. They're all superconductive. They will have these geomagnetic induced currents induced within them because these currents want to flow along whatever is most conductive. That's just how electromagnetism works. When you have this magnetic field that's varying, it's not going to induce a strong geomagnetic induced current in something that's fairly resistive. It's not conductive. So let's say you have like marble. Marble is a rock type that's not that conductive. The geomagnetic induced currents flowing through that marble, they will exist, but they won't be that strong. But you have, let's say, aluminum, which is like 10 or 15 orders of magnitude more conductive. The strength of that electric current that's induced is going to be dramatically higher. And again, as that voltage potential raises up because of these induced currents, at what point does the power grid collapse? What's its safety rating, you could say? And if it gets strong enough, 2,000 volts in excess or 5,000 volts in excess, we don't know what a super flare impact will do, then that could just totally overload everything. And how long will it take to rebuild this stuff? I mean, it can fuse and melt things and just completely obliterate stuff. That's the big fear with an electromagnetic pulse being dropped and detonated. And effectively, when you get a really big solar storm to hit Earth, it's effectively an electromagnetic pulse that occurs globally, though the strength and effects of that will be strongest in the polar regions because that's where most of the energy flows down. So it's really important to understand these geomagnetic induced currents as it relates to this scenario, and also as it relates to our health, because these energies also connect with us, as we discussed. And when you're standing on the ground, you're connected to telluric currents and the rhythms that they're pulsing at. And all this energy can be very stressful to the body, but I think what would be even more stressful probably, it would be if there is some sort of societal chaos and event that results from a super flare impact. And back in 1859 at the Carrington event, massive solar storm impact, supposedly, they estimate that solar flare was an X64 in strength, a very powerful solar flare. It really didn't do much though societally. Yeah, some telegraph operators were affected, but it's not like it caused societal chaos or anything or a big collapse because this was 1859. Well, nowadays, it would perhaps be devastating. We just don't know what would happen if that occurs. But based on all the available evidence, what we're seeing, we are making ourselves more fragile to these sort of solar storm impacts than we ever have been before because of how we're altering the natural geophysical layers. If we're being realistic, it's not likely that we're going to change our path towards greater technological advancement. In fact, I think hoping for a return back to a more normal way of life that's in greater harmony with the Earth, while really amazing, is in some aspect putting our head in the sand and avoiding the reality of the situation and therefore preparing what is going to occur, because there's no signs that we are going to just completely shut off our technology and go back to a simpler way of living unless we're forced to by something like a solar flare. And so that may be what happens. What we see is that every now and then the sun emits an extremely powerful solar flare. And it's very likely that this is something that doesn't occur that often because it's such a high intensity. And so you have more frequent solar flares as they go down in intensity, and then the most powerful ones are going to be more infrequent, but we do see them occur. 774 AD being a good example. There was a recent study that came out that looked at a whole bunch of sun-like stars, and they saw that the average recurrence interval for superflares from that sample was about 100 years. Now there's some nuance to that study, so it doesn't directly apply to our sun. But regardless, we know that superflares do occur not only from our sun, but also from other stars that are sun-like in nature. G-class main sequence. And a superflare is so much more powerful than anything that we have dealt with in recent history, especially in this modern technological age. So we just don't know how it would affect us. And that's really the unknown. And we hope that we don't have a superflare anytime soon. But because of how we're developing our technology and how it's becoming increasingly widespread, it is only a matter of time before something like this happens, or at the very least, something like a Carrington event. We know that those occur actually quite frequently, about every 50 years or so. And yeah, that is a very big thing to just know that it exists. There is that potential. This is not something that is made up to scare you. We have geologic evidence of Miyake events throughout the recent record, 774 just being the most recent example. And based on how we're altering the geophysics of this planet, it could amplify the effects of a solar superflare impact well beyond what Earth normally experienced in the past. And so that is one of the realities of the future I think we have going forward, something that we have to prepare for and to be ready for. Again, this isn't a prediction. This isn't, we're going to have this happen at this date. This is just outlining a lot of the different potentials and possibilities that exist, some of the known science and some of the science that has been done and research into, but is not talked about on the mainstream because a lot of people haven't put these kind of dots together. So that's what the purpose of this video is. I hope you found that useful. I'll continue talking about it and researching more into this. So if you'd like to stay appraised, then please subscribe to my channel. I release videos almost daily. I've talked about this a lot before, but I really needed to make a comprehensive video on this topic. So if you liked it, smash that like button, share this with as many people as you can, anyone that it will resonate with, because this is something that needs to be shared very widespread. We need a lot of people on this planet to be aware of this. Ideally, everyone, in my opinion, should be aware of the direction the Earth is going, because we distract ourselves with these minor things in the minutia. But what's really important is our planet and how we live on the planet and the relationship that we have with the planet and where things are going and what may happen. Because the effect of a superflare on an extremely technologically advanced but weak society could be absolutely devastating. We hope it doesn't happen, but I wanted to discuss what I've been seeing as a geophysicist who 5 years ago was new to all this, and I researched into the Schumann resonances because I kind of learned about them. I thought they were interesting. The more I researched into this, the more I learned, the more I became aware, and the more that this presents itself as a real possibility. So again, I've been your host, Stefan Burns. Thank you all so much for watching. I'm wishing you all well. Blessings to all of you, and I'll see you all in a future video.